Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. NBS, N-bromosuccinimide, is a reagent used for allylic or benzylic free radical bromination under light or peroxide conditions. It selectively brominates the CH bond at the position most stabilized as a radical. Moving on to the next step. The starting material is 1-methyl-1,2,3,4-tetrahydronaphthalene. The ring system is a fused bicyclic compound where one ring is benzene and the other is a cyclohexane ring. The methyl group is attached at C1, which is the benzylic position adjacent to the aromatic ring. Moving on to the next step. C1, benzylic, tertiary bears the CH3 group and is part of the ring. However, C1 already has no H because it carries CH3 and is a tertiary carbon attached to the ring. Wait, let us reconsider. C1 has 1 bond to benzene ring carbon, 1 bond to CH3, 1 bond to C2 of cyclohexane ring, and 1 bond to C8A, the other ring junction. So C1 is a quaternary carbon if it has no H. Actually, in 1-methyl-tetraline, C1 has aromatic ring C, CH3, C2, CH2, and C8A, making it a quaternary carbon with no H available for abstraction. The CH3 group at C1 is a benzylic methyl group. Abstraction of H from this CH3 gives a benzylic primary radical, PHCH2 type, stabilized by benzylic resonance. C2 secondary, non-benzylic, 1 carbon removed, less stable radical. C4 benzylic secondary position, adjacent to benzene ring on the other side, would give a benzylic secondary radical. And for the final step, the CH3 attached to C1 is directly benzylic. Abstraction from CH3 gives a primary benzylic radical. C4 is also benzylic, secondary benzylic radical. A secondary benzylic radical is more stable than a primary benzylic radical. However, option A shows bromination at the benzylic CH3 position, giving CH to Br, and option C shows bromination at C4. Option A shows Br at C1 with the methyl still present and Br on the ring carbon, indicating tertiary bromination at C1. But C1 has no H, it's quaternary. So option A cannot arise from H abstraction at C1. Looking more carefully at the answer choices and the given answer being A, option A depicts Br at C1, the carbon bearing the methyl, meaning the methyl bearing carbon gets brominated. This is only possible if C1 is tertiary, has one H. In 1-methyl-tetraline, C1 is indeed tertiary, it connects to the aromatic ring C4AC8, a junction carbon, CH3, C2 and 1H. So C1 is tertiary and benzylic. Radical stability at C1 versus CH to Br, side chain a tertiary benzylic radical at C1 is more stable than a primary benzylic radical at CH3 or secondary benzylic radical at C4. NBS selectively abstracts the H at the most stable radical position. Therefore, NBS abstracts the tertiary benzylic H at C1, generating a tertiary benzylic radical, which is then trapped by Br from NBS to give 1-bromo-1-methyl-1-2-3-4-tetrahydronaphthalene. Why other options fail? B. Bromination at the CH3 side chain gives a primary benzylic radical, less stable than tertiary benzylic, so not major. C. Bromination at C4 gives a secondary benzylic radical, less stable than tertiary benzylic at C1. D. Bromination at C2 gives a secondary non-benzylic radical, least stable, not preferred. Therefore, the correct answer is A. Therefore, the correct answer is option A.